pressure to higher.
Tatanong lang ito.
Next refresher to. If you guys are
A
struggling
pump
with
is a
pumps,
device used to move liquids or slurries. A pump moves liquids from lower pressure to higher pressure and overcomes the difference in pressure by adding energy to the system. In general, pumps can be classified as either positive displacement or dynamic. Dynamic pumps move liquids either axially or centrifugally. Centrifugal pumps operate on the principle of centrifugal force. A spinning impeller inside a casing propels liquid outward. Axial pumps utilize a similar motion, but the motor turns the propeller, forcing the water through on a straight line. In dynamic pumps, the discharge pressure determines the amount of fluid that is displaced. A positive displacement pump moves liquids using a rotary or reciprocating motion that displaces the liquid on each rotation or stroke. Positive displacement pumps displace a specific amount of fluid no matter what the pressure is. Rotary pumps use the rotation of screws, gears, vanes, or similar elements to displace the fluid. Reciprocating pumps draw fluids into a chamber on the intake stroke and push them out with a piston, diaphragm, or plunger. Slip is defined as the percentage of the fluid that leaks past the internal clearances of a pump. In other words, slip is the difference between how much fluid a pump can move and how much it actually moves. A dynamic pump can have as much as 100% slip if the discharge is closed. As the fluid enters the pump, the flow is accelerated to the discharge by the impeller. If the impeller continues to turn while the discharge is closed, all of the fluid will slip through the internal clearance. Positive displacement pumps are designed to have minimal slip. Physical law states that no two objects can occupy the same space. Something has to give. Therefore, if the discharge is closed, the following conditions exist in a positive displacement pump. Very little, if any, slip will occur. Fluid pressure will increase with every stroke. Fluid pressure is transferred equally to all isolated parts. The pump can be damaged if a relief valve is not provided.
Nice, mas nagets ka doon. Internal slip.
so yung suction, papasok, the fluid will be forced out following the rotation of the vein, doon dadaan, tapos lalabas siya doon. Kaya ginagamit palagi centrifugal pump sa tubig is because of that property of slip. Pag sinunado kasi yung valvula, yung tubig, iikot lang dito, mag-slip. As opposed to positive displacement pumps na hindi natin ginagamit sa water
Axially or centrifugally propels liquid outward, amount of fluid that is displaced. Fluid, no matter what.
Ang positive displacement pump, suction, papasok dito, hindi makakadaan yan kasi silyado, dadaan siya dito. Doon sa cavity. Okay, tapos dito magkikita, tapos sa labas. Hindi ginagamit yung ganito sa tubig. Dito kasi pag sinara mo, nasabog yung bomba. Kasi it's positive. Similarly, this is a plunger type moves up and down. You're familiar with the yung paboka kayo din insecticide, di ba? Your type. Hindi rin ginagamit yan except for metering kasi pag sinarado mo yung valve, sasabog yan. Okay? Kaya makikita niyo palagi sa mga tubig, puro centrifugal pump. Nakakita na kayo ng centrifugal pump. Right? Can you tell me the parts of the pump?
Paano?
Watch another movie.
Yan naman.
Centrifugal pumps are a dynamic pump that operate on the principle of centrifugal force. Centrifugal force is a force that tends to move objects away from the center and assist them undergoing circular motion.
Tandaan nito, yan ang i-inspect nyo sa
The casing of a centrifugal pump is designed to contain the fluid, form a volute, and hold external and internal parts together. Most are two pieces and bolts together with a gasket in between. A radial split casing is split perpendicular to the pump shaft, and an axial split casing is split parallel to the shaft. The volute is a gradually widening cavity inside the casing, which serves as a discharge for the pump. The inlet to the valve is commonly referred to as the suction eye. Fluid enters from the center and is spun outward to the volute by the impeller. In order to operate correctly, the inlet line must be primed. The impeller is a set of blades that rotate around the drive shaft, which spins and transfers the fluid from the center to the discharge. The driver can be either an electric motor or steam turbine. The shaft is what connects the driver to the impeller. The stuffing box and packing gland hold the packing against the shaft and casing. This allows shaft movement through the casing while at the same time preventing leakage from the pump. If a pump was said to be horizontal, it means that the shaft is horizontal to the ground. Horizontal seems to be the most common type in industry. However, vertical pumps are more compact, winterize better, and tend to have lower installation costs. The simplest type of centrifugal pump is a single-stage pump. A single stage has only one impeller. In a multi-stage pump, the fluid enters the suction eye of the first stage impeller and is sent into the suction of the second stage impeller. The fluid flow and pressure will continue to increase at each stage until it reaches the discharge. Most centrifugal pumps have just a single inlet. Some applications require a higher volume of pumping. In these circumstances, a pump with more than one suction can be used. Impellers come in three basic designs. An open impeller has vanes that are only connected to the shaft. It is self-cleaning but has very little structural support. A semi-open impeller has the vanes connected horizontally to a plate on one side for more support. The vanes of a closed impeller are closed in between two plates for maximum support. This is the strongest, most common, and most efficient design, but it is limited to use with clear liquids only.
So, karamihan tubig.
Pressure head is a convenient term used in pumping to describe the pressure required to force liquid into a pump. order to calculate the system, you will need to know the static head on both the suction and the discharge side of the pump. In addition to the static head, there are two more heads you will need to know to complete the calculation. The static head of a pump is the maximum height or pressure you can deliver. Static head is due to gravitational force on the column of fluid. The head caused by resistance in the piping, fittings, and valves is called friction head. Surface pressure head is caused by any pressure that might be acting on the liquid tanks, including atmospheric pressure. The total suction head consists of three separate heads. The total suction head equals suction static head plus suction surface pressure head minus suction friction head. The total discharge head is also made up of three separate heads. Discharge head equals discharge static head plus discharge surface pressure head plus discharge friction head. To calculate the total system head,
Okay, let me just make this clear. Marami kasi ako na-encounter na nag-i-install ng mga piping, they do not understand this basic. This is just a refresher. I'm sure you studied this already. These are just people keep on forgetting. Ayaw nyo ng maraming elbows or mga bends sa pipe because it causes friction losses, correct?
Yes.
That means, kung kayo mag-design ng mga piping systems, dapat halos diretso-diretso yan. Ayaw nyo ng pasikot-sikot. Kasi nga, marami kayong friction losses. Basic rule. Another thing, kung kayo ay maraming elbow at fittings, gagamit kayo ng maraming materyales. Each elbow is expensive, lalo na kung stainless steel ang ginagamit nyo. So the less elbows, fittings that you will use, the better for your design, the more efficient. Okay? Ganun lang. Keep it as straight as possible, as few connections as possible. You will have a very happy pumping system. That being said lang, everywhere I go, when I look at the piping system, yung engineer na nag-design dito, kung saan pinapapunta yung tubo. That's one of the problems why yung mga plumbers gusto nila maging engineers. But they keep on doing those simple mistakes. Kaya, I don't know if they will be good engineers.
subtract the total suction head from the total discharge head.
I'm assuming you're familiar with all of these terminologies, ha? Ito na yung cavitation na binanggit nyo.
Cavities, or air pockets, form in the fluid being pumped. It is called cavitation. Cavitation occurs on the suction side of the pump. There are 5 basic causes for this: vaporization, air ingestion, internal recirculation, flow turbulence, and the vein passing syndrome. The effects of cavitation are: the cavities or bubbles will collapse when they pass into higher regions of pressure, causing noise, vibration, and damage to many of the components. You will also experience a loss in capacity. The pump can no longer build the same pressure, and the pump's efficiency drops.
You didn't sabi about cavitation kanina. Tell us more about cavitation. Is that good or bad? Bakit? Okay, correction. Cavitation is, you don't want it because it causes a lot of problems. Whether your impeller or your pipe is copper, brass, stainless, cast iron, masisira pa rin siya. Okay, so, yung cavitation kasi are like mini explosions and will hit all of those materials, especially the impeller. Plus the fact mag-vibrate yung system mo. But again, assuming this is just a refresher's course. Have you seen effects of cavitation? Nakita niyo yung picture.
Hindi. Picture.
Yeah, parang pimple na face. That happens very frequently. You can imagine if have you ever seen the big pipe pump of Maynila? You can imagine yung mga tubo ng Maynila napakalaki, di ba? So yung bomba ng Palos, malaki rin. So imagine siguro isang impeller, 100,000. Mura na yan. Tapos masisira every few months. Laking gastos nun. So you don't want to have that situation. There were 5 items enumerated on the possible causes of cavitation. You remember them?
Yeah.
So many engineers don't even know how to address the problem of cavitation. Ano yan?
Yung syndrome.
Producing of air bubbles.
There are 5 basic causes for this.
Pay attention here.
Vaporization,
We vaporize,
air ingestion,
air ingestion,
internal recirculation,
we recirculate or nag
flow
slip,
turbulence,
turbulent flow.
and the vein passing syndrome.
What's a vein passing
The
syndrome?
effects of cavitation are the cavities or bubbles will collapse when they pass into higher regions of pressure, causing noise, vibration, and damage to many of the components. You will also experience a loss in capacity. The pump can no longer build the same
Pag wala na
pressure.
yung impeller mo,
Pump's
syempre,
efficiency
you cannot
drops.
build up the pressure anymore. Your efficiency will drop.
Rapid swings in the discharge pressure are one way to recognize cavitation. Another way to recognize cavitation is by sound.
Most common, maririnig nyo,
Cavitating pumps
maingay.
resemble the noise of steel ball bearings being introduced into the pump.
The tinging sound, yun yung mga
Cavitating
buckles.
pump must be resolved quickly in order to avoid severe damage. Some advantages to centrifugal pumps are cheaper costs, less maintenance and space are required. Another advantage is that they will work with a constant head pressure over a wide capacity range. The final advantage is the variety of drivers available to use. Centrifugal pumps do have some disadvantages too. They are not self-priming and respond poorly to viscous materials with suction pressure. Thank you for viewing this procedure. If you need to test,
Okay, so centrifugal pumps are the most basic pumps you will find, especially sa tubig. And the reason for that is, hindi nila kaya yung viscous products. Pag medyo lumalapot na, then you go look at another pump. We'll cover those pumps more. Now, let's continue the lesson on water system. Okay, nagbomba ka na, nasa taas na, now you'll be bringing this down to your different units. So let me ask, tama ba yung diretso tayo dito into the units o kailangan pang idaan muna sa tangke bago pumunta sa units? Dapat yung isa ng bahay.
Tangke bagi yun.
Bakit? Para may continuous why can't you just get it direct from the pump? Okay. Well, ano sa palagay mo ang pressure dito pag didiretso ko sa bahay mo? You said it was 100 eh. Kung galing sa overhead tank, anong pressure? Palagay mo.
Dahil sa law,
So, ano sa palagay mo ang pressure mo dito. Kuha tubig.
Gi-introduce ka ng pressure relief.
Mas mataas pa sa 100. What do you think is the pressure on this line?
Increasing.
By gravity. What do you think is the pressure at the bottom of this? You have a 50-story building.
Mataas. Hindi.
How did you calculate 150?
Kasi may gravity sa positive pag discharge ng positive na yung pababa.
Ano naging malaki? We're talking about the same example, huh? So, 50 stories, each story is 3 meters. So, 50 times 3, 150 meters. Ano pressure at 150 meters? Diba? Come on, I thought you studied this. Ano pressure nyo sa head ng 150 meters? Gravity pa lang yan.
Zero.
Here's a clue. 14.7 PSI is roughly equivalent to 33 feet. Okay. It is a water column. Anyone read?
10 point something.
Ako yung question, ako may impress.
67. 66.8.
How did you get 66? How did you divide this? Oh, question na tayo. Feet tapos meter.
Yan.
6.8 feet. IPSI, sir.
0.8 PSI.
66.8.
66.8 PSI. Tama ba yan?
Yung ayun ako, Pitbull. 66.8 ka ba?
What about the others? What are you doing? Are you listening?
Yes, sir.
Oh, what's your answer?
220 PSI.
Oh, laki ng answer niya. 200 na siya. Gravity pa lang yan. Gravity pa lang yan. How did you get 200?
150 meters divided by almost 10. Kasi 10, kahit 10 ba? Hindi ko mahalala yung conversion eh. 3.28.
Ano ba?
Tama to everyone else. Let's do this.
200 ba?
Meters. 10.3 ba? 10.3 meters ang water column ba? Kasi 33 feet.
Yes.
Hindi ko naman talaga.
150 meters. Madali yun eh.
Convert mo lang sa feet. Convert mo lang sa feet. Tapos
150 meters convert mo sa feet. Tapos 230 times 4. Divide mo sa
kasi convert mo lang PSI. Convert mo.
kasi convert ko na yun. Kasi yun yung 14.7, i-ratio mo sa 33. 119. Wala, kailangan ka ng calculate. 100 so 19.
Mas pala.
492.
Tama naman siya, 220 ah.
Well, it's not a good idea kung nakakabit ka sa overhead tank. Kasi yung tubig na lalabas,
Tama nga, 20 nga.
220.
that will knock down your wall.
120.
Yeah, kung gagamitin mo yung pampaligo, tanggal lahat ng buhok mo niyan. So, ano gagawin natin?
Pressure relief, sir. Pressure relief.
kahit maliit na, ipat pa rin yan. What do you do?
Pressure reducer.
Pressure relief, sir.
Pressure reducer, saan mo lalagay?
Bandang dulo.
Hindi.
Pressure relief valve relieves the pressure of the system. Isirit lang yan. Kung magkano ang pressure relief valve sa positive displacement. You don't normally put that sa feeder line.
Ah.
So how do you reduce the pressure? Kung nakatira ka sa condo, 200 PSI na lang. Sige, 200 PSI. Pwede mo kayo gamitin yung tubig ka. Tapos kinamahan ka niya, bubog-sarado ka. Water massage yan. So, bakit naman mangyayari sa'yo? So,
Lalabas dito yung tubig.
Yung pressure ang gusto mo sa shower. If you ever try 200 PSI in shower, yung swimming mo kasi mas easier. Anong pressure gusto niyo sa shower niyo?
20.
10 PSI lang. You don't want much pressure. So how do you reduce from 200 to 10 PSI yung water system mo?
Lagyan ng relo konting
You know, kahit yung malaking tubo sa shower room.
Yung dulo.
Eh, yung umaga pa, magluluto. Pagbukas ng gripo sa lababo, choo! Butas yung mga kaldero nyo dahil bubutasin ng 200 PSI yan. So how do you bring it down? You cannot release 200 PSI sa pipe. More than anything, sasabog yung tubo mo.
Storage tank.
Oh, saan mo lalagay yung storage tank?
Ah, sa taas.
May storage tank na nga eh.
Another one. Ah.
Ano yan?
Nakalimutan ko yung term.
Pwede po sa storage tank.
At the top.
Ano ba yung design mo? Lagyan na dito.
VFD, control, constant pressure pump set.
Ayan.
Electric. Pag kaya may bomba dito sa baba, hindi nyo na kailangan ng bomba sa taas. Kasi sayang ang pera nyo. Bakit kayo magbobomba doon? Kasi magbobomba. How do your magnesium solve it? So how did they reduce the pressure?
Constant pressure pump.
Increase the size of the pipe.
Oh, how did you solve the problem of pressure by putting it parallel? The pressure is the same. You put a check valve, which direction ang kine-check mo? Going down, going up. Hindi walang tubig sa baba. Pag iniwasan yung tubig, when shutting off if you shut off the valve, you're reducing the flow of water, but the pressure is still there.
Ah, sir, loop.
What do you think?
Sir, loop. Dali ka maglulup. Sir, lulup, sir. Ilulup.
Ilulup mo going up again.
Hindi, sir.
Eh yung bahay, yung unit mo nasa baba eh. Bakit mo ilulup? If you loop it down, you're still talking about the head. The head does not change.
Ah.
See, you make it a loop, the head is still constant. The pressure is still the same. How? So when you put the reducer, so by putting a reducer, you're not affecting the head because the head is the same. You're just restricting the flow. So, ang papatak dyan dun sa baba, patak-patak at 200 PSI. What's that? Yeah, what's that? What's a regulator? How does it work?
Parang ano sa sir? Parang sheet na huli niya ng muna sa IPE. Lalabas.
So, saan mo ilalagay yan? Tubo. Dito yung pinili natin. Somebody suggested put a tanke in the middle. You're suggesting to put a regulator. Ano yung solution ng condominium mo? Hindi kwento about the Romans 2,000 years ago, di ba? Yung condominium nila, maximum ano nila is up to 4th floor lang. Normally. Kasi unang-una, yun lang technology kaya ng semento. Pangalawa, pagdating sa 4th floor, mahina na yung takbo ng tubig kasi by gravity lang sila. They use basically the static head. So yung malakas na tubig dun sa ground floor. Kaya nga, mga condominium sa Roman times, pag mayaman ka, doon ka sa ground floor. Yung malakas ang tubig. Kung mahirap ka, dito sa taas, yun ang patak-patak yung tubig. Kaya lang, karamihan nga sa kanila, kukuha dun sa fountain. Mag-iigit dun sa bahay. Now, the other problem also, did I show you the lead pipes, the Romans? Problem is, yung lead is not very strong. Pag masyado mataas ang pressure, pumuputok yung tubo nila. So they really cannot go high hanggang 4th floor. But with today's technology, we have skyscrapers, 100 stories. What's the tallest building on earth? Ilan floors? Plus. Could you imagine? How do you get the water up there? It's in the desert. Pupasok yung engineers. Tapos, same problem, yung overhead tank mo, if your overhead tank was 100 floors, kung dito, 50 pa lang, 200 na, kung 100, 400 PSI yung tubo sa baba. Kung ang lalaki ng tubo mo, kasi ang lakas ng pressure, pagbukas mo, patay lahat yung mga tao doon. So how do you solve the problem of high pressure? So bakit po maakit? You need the water downstairs. Oh, the head is still the same. Yeah, you didn't change the head.
Lalagay mo sa ano, sa fire pro. Lalagay mo sa fire pro.
So, fire?
Fire protection.
Iba yung fire protection sa domestic water. Iba pa yun. Sa fire protection, kailangan mo yung pressure, high pressure kasi bumubomba ka eh. So, okay lang yun. Pero ito, iniinom mo. Pag pinangguluto, pinanliligo. Hindi ka pwedeng mag 400 PSI dyan. Tanggal yung malas mo. Patay. Yes.
Kailangan pa talaga yung supply galing sa taas.
Kaya nga mag-design ng water system. That's why I'm asking you the question. Normally, we want to take advantage of the height. So, kaya naglalagay tayo ng mga tangke sa taas ng bubong. Sino dito may nakakita na ng building, may tangke sa gitna ng building? Akit kasi elevator. Oh, hindi ako makadaan, may tangke sa gitna ng elevator. You don't do that. So how do you solve the problem? It's being done, but how? Madali yun sa bahay, sa second, fourth floor lang. The building becomes an engineering problem. So doon pumapasok yung mga calculations na pinuro sa inyo. Kasi sa planta, normally, meron kayong overhead tank. Normally, malalaki yan. Matataas yan. Tapos, ipapipe nyo by gravity para makakatibig kayo sa kuryente. How do you reduce the pressure? Oh, you find the answer?
Di ba? Galing mo din naman yung pressure.
Dun sa schematic na sa building.
Di ba gravity nagbababa na?
Ha?
Di ba gravity nagbababa?
Oo. Hindi, problema kasi daw mataas sa pag doon lang sa pinakababa. Paano mo may re-reduce yung pressure?
Hindi yung reduction bag.
We're looking for a solution to your water problem.
Di ba may ganun?
Oo.
Dalawa yun eh.
Pero alam ko, doon sa condo na yun ako, meron din silang pump doon sa taas.
Pag mataas.
Oo, multi-stage.
Ilang story ba yun yung building mo? Kasi alam ko, pagdating sa kalahati,
Nasa trend.
nagpapump din sila. Pag sobrang taas, nagpapump
Ano,
sila.
di ba? Hindi, yung simula sa taas, pa-supply na.
Supply, nagpapump sila din.
Naka-multi-stage. Naka-multi-stage yun.
Meron kang water pump, taas. Or what?
Yun, naka-multi-stage.
Okay? May booster pump. Ano yung galing mo ba? Galing sa baba.
Transfer pa, kasi ito yung tapping from
Alam niyo na bakit ganyan yan? Kasi bawal, pinagbabawal ng Maynila, connect kayo directly sa main na may bomba. Kailangan may cistern. Tawag dito, residential water tank or cistern. Tapos pinabomba niya, may bomba siya paakyat sa overhead tank. From the overhead, how does it bring it to the different units?
Johnson's baby clone.
Kaya we see
Ito na itong pamataas na naman.